Welcome to Math Mantra. In today's class, we are going to learn about LCM and HCF. So before going to start the session, let us recall what is LCM and HCF. LCM is least common multiple, whereas HCF is highest common factor. There are several ways in order to find the HCF. First, we are going to see how to find out HCF using prime factorization. We have to follow certain steps in order to do it. The first step, find the prime factorization of each of the given number. So here, for each and every number individually, we need to find out the prime factorization first. The product of all common prime factors is the HCF of the given numbers. So first thing, we have to find out the prime factorization for each number. Then we have to pick the common factors. Then those common factors need to be multiplied, which will give us the HCF. Where we'll be using it? If you get a question saying reduce 12 by 56 into its lowest form, then with which number you are going to divide both the numbers, the numerator as well as the denominator? So if you find out the HCF and divide both the numerator as well as the denominator, then the task will be very easy. So let's see how to do it practically. The question, find highest common factor, that is HCF of 12 and 56 by using prime factorization method. So as we have discussed individually for each and every number, we need to find out the prime factors. This is how we need to divide. See here 12. So always remember, only with the prime numbers you are going to divide the number. Okay, so here we have 12 and with 2 you need to start. 2 6 are 12. The quotient will be written over here. So 2 6 are 12. 2 3 are 6. 3 1 are 3. In same way for 56 also we'll do. See here 5 is there. First we need to consider the leftmost digit. Okay, so when it is more than 2, how you have to do individually? You do 2 2s are 4. So 5 minus 4 is 1. Think that 1 is here and keep the 6, so it will be 16. 2 8s are 16. Okay, that is how we have to analyze. Then 2 1s are 2, 2 4s are 8, 2 7s are 14, 7 1s are 7. So here what we are doing, the quotients we are writing in next step. So here I have listed the prime factors, and here the common factors we are going to see. Common factors, which is nothing but the factor which is common in both the cases. Here 1, 2, 2, that's it. Because 3 is here, we don't have any 3 over here, and here 7, so we don't have 7, so we'll not take it. So common factors of 12 and 56 will be 1, 2, 2. So in order to obtain HCF, what we have to do? We have to multiply the common factors. So here is the multiplication. So you no need to consider always 1. So directly you can go ahead with 2 and 2. You can multiply them so that you will get 4. So 4 is the HCF of 12 and 56. Next, we find out the HCF of greater numbers 378, 180, 420 using prime factorization. So directly I have written the factors. So please take one pen and paper and find out the prime factors of each number. So for 378, try to find out by your own and you just compare with the answers provided. So here I have listed the prime factors which we obtained, and here we have the prime factors. See here the common factors 2 here. So 2 is not repeating in first case, so we just need to ignore, and 3, in all 3 cases it must be there, then only we call it as common factor. Okay, and in none of the cases, none of the numbers are repeating in 3 places, so we just ignore. So the common factors are 2 and 3. We just need to multiply and we'll get 6 as HCF. So this is for your practice. Please take your pen and paper, pause the video right here, and you just try to find out the answer. The answer will be provided. So if you really wanted to learn, please don't go forward, pause here and you just try and check with the answers. If you are getting really 12 and 42, you are perfect in doing prime factorization. So far we have seen how to find out the HCF using prime factorization, and here we are going to using division method. We are going to see how we will be finding the HCF. Find HCF of 36, 24 and 48 using division method. So here what we have to do is, it is quite simple. What we have to do is, by placing comma, we have to take all the numbers. So 36, 24, 48 at a time we need to take. So make sure that all 3 numbers must be divided by one number, then only we can divide. See here, with the 2, 36 is divisible, 24 is divisible, 48 is divisible. Always remember, all the even numbers can be divisible by 2. So what do you mean by even numbers? In ones place, if you have 2, 4, 6, 8, 0, so those are known as even numbers. So all the even numbers can be divisible by 2. Since I have all 3 are even numbers, I am going to divide with 2. So 2 ones are 2, so 3 minus 2 is 1, 6 you take, 16 will be there, so 2 8s are 16. Okay, so if you are new for this HCF and finding the division, so you can write roughly and you can still find the quotient you need to write here. 2 1s are 2, 2 2s are 4, 2 2s are 4, 2 4s are 8. So this is like directly, because you are in 10th grade. So for 9th and 10th grade, I encourage this method, because directly you must know how to solve, because we can't spend more time. Okay, so these are the shortcuts we need to learn. Okay, when we see this question, okay, since we have 8, 2, 4 in ones place, still we can divide all the numbers with 2. So 2 9s are 18, 2 6s are 12, 2 1s are 2 2s are. So 2 12s are 24. So now I got my next step. So here I need to divide by 3, because see here, 9 is odd number, 6 and 12 can be divisible by 2, but still we cannot divide 9 by 2, so we are not supposed to use 2 again. This is the main rule we have to remember in HCF. When all 3 numbers are divisible with one number, only that time we have to divide, or else we are not supposed to do it. We have to stop it over there. See here, 2, I could be able to divide all these 3 numbers, I divided. Here though two numbers are divisible by 2, one number is not divisible also. I am not supposed to divide by 2 in HCF. Okay, so now with the 3 I will try. Yes, 3 3s are, 3 2s are, 3 4s are. Yes, all these 3 numbers are divisible by 3, so I can take 3. So 3 3s are 9, 3 2s are 6, 3 4s are 12. Okay, and these numbers we cannot divide with a single number, so what we have to do, we have to stop it. Okay, and we just need to multiply the common factors 2 2 3, and these numbers we have to ignore, we are not going to take it further. Okay, so common factors will be only these 3 with which we have divided so far, so those will be called as common factors here. So we are going to list them here, and we just need to multiply them. 2 into 2 into 3, that is nothing but 12. So the HCF of 36, 24 and 48 will be 12. So you can find the HCF of 126, 168 and 210 using short division method. Make sure that you will use the same rule. All 3 numbers must be divided with one number. You have to take the prime number, so then only you can go further. Okay, please do remember. So if you are getting answer as 42, yes, you are perfect in doing short division method. Okay, so all the very best. Next we'll go to LCM. So far we have seen how to find out the HCF using prime factorization and the short division method. Now we are going to see how to find out the LCM using prime factorization. It's just similar to HCF. First thing, we have to find out the prime factors for each number. The only thing here we have to follow, we have to represent or express the factors obtained in exponent form. Okay, in our problems we are going to see how we are going to represent the obtained one in exponent form. And here what we have to do, like we have to compare all the exponents, like all the numbers, then we have to find the product of the highest powers of all the factors that occur in any of the given numbers. Okay, so now we are going to see what's that practically. So here, like when they ask us to find the LCM using prime factorization, first thing what we have to do, the finding of the prime factors, it is same as HCF only. See, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are. So the quotients we need to write, again we have to divide. Okay, and make sure that when you are doing the prime factorization method, division method, make sure that you will be using the prime numbers. Okay, so next here, see for 16, 2 into 2 into 2 into 2. So 4 times 2 was repeating, no? So I will write 2 to the power 4. Okay, and same way here, 28 can be written like the factors of 28 is 2 into 2 into 7. So here 2 being repeated for 2 times, so we will write 2 square into 2. Okay, and when we compare here, the highest, like 2 square is there, 2 to the power 4 is there. So in our previous slide we have seen we have to find the product of highest powers of all the factors. Okay, so which is having highest power comparatively, here 2 to the power 4, it is having highest power. Okay, and here 7 to the power 1. So here 7 is not there, no, so we have to consider 2 to the power 4 into 7. Make sure that you will take the highest power number, as well as here 7 power 1, we don't have any other number, no? So we have to consider the 7 and we have to multiply. This is the main difference between LCM and HCF. Okay, don't get any confusion. It is very easy. See here, so now 2 to the power 4 I have taken into 7. So 2 to the power 4, it's nothing but 2 into 2 into 2 into 2 into that 7. So when we multiply, we'll obtain the answer 112. Okay, so the required least common multiple of 16 and 28 is 112. Okay, so since it is multiple, obviously, so multiple, which means that in 16 table also you are going to get 112 and 28 table also. So this is least common multiple, so you might be having idea of it. Okay, I'm just reminding it. So next we see another question. Find the LCM of 8, 12, 16, 24 and 36. So prime factors directly I'm writing for 8, 12, 16 and 24 and 36. Okay, so here I have written 2 cube, 2 square into 3 power 1, 2 to the power 4, 2 cube, 2 square, and here 3 power 1. So this is part symbol I have used. Okay, so here when I compare all the common, all the factors, this is having highest part. Okay, so I'm going to consider 2 to the power 4, and among all these 3 square is the highest part, no? So I'm going to consider both 2 to the power 4 and 3 square. So I'm gonna multiply. That is 2 to the power 4 means 4 times 2 into 3 square means 3 into 3. So when I multiply all this, so I'm gonna obtain 144. Please you just find out the prime factors and try to write it into exponent form. So next, division method. So here same way as we have found for HCF, in same way we are going to write in horizontal line by keeping comma in order to separate them, and we are going to divide in each level, and we are going to write the quotient in next step. So this is what they have told, and we will be keep on repeating it until we get the co-prime numbers. So what do you mean by co-prime numbers? When all the quotients are prime numbers, like 2 and 3 or 5 and 7, something like that. If you, until you get co-prime numbers, you have to repeat. Okay, so now we'll see practically. What is the least common multiple LCM of 18, 24, 60 by using division method? See here we have done, see, with 2 I have done 2 9s are, 2 1s are, 2 2s are, 2 3s are 0. So once I have done with this step, here I'll be, so in HCF I must see that all 3 numbers will divisible by 2, but in this case it's not like that. If one number is divisible by 2 also, we'll be making use of it. Okay, so here 2 numbers can be divisible. So what I am going to do, 2 9, so 9 will be written as it is, we should not change it. 2 6 are 12, and 2 1s are 2, 3 minus 2 will be 1, so it will be 10, no? So 2 5s are. Then with 3, let us go ahead, 3 3s are, 3 2s are. If you want to do with 2 here itself, you can do, you are allowed to do. So 3 3s are 9, 3 2s are, 3 5s are. Next 3 1s are, and 2 we have to write as it is, 5 we have to write as it is. See here actually we got prime numbers, both are prime numbers only, no? So we can leave here itself, or if you want to proceed, you can proceed. 2, see, this one will be written as this, 2 ones are 2, and 5 will be written as this. Then we got 1 comma 1 comma 1. So until you get 1 also, you can proceed, or when you are getting both are like prime numbers, you can stop over there. So now what we have to do, so we have to multiply all these multiples. Okay, so sorry, in order to get LCM, we have to multiply all this. Okay, so 2 into 2 into 3 into 3 into 2 into 5. So we'll get 360. So make sure that you will go through the video again. Please try to understand. It is a little bit tricky. If we follow the steps properly, we are going to get the good answer. And it will be practice if you keep your pen and paper along with the video. If you, while watching, if you do know, definitely you are going to learn. Okay, so please like the video, share it with your friends, and don't forget to subscribe my channel Math Mantra by Tipanagari Radha. Thanks for watching.